Hello everybody, welcome back. We're now looking at dividing rational expressions. So, very similar to what we did with multiplying, although the first thing you want to do is you want to change it to multiplication, right? And then once it's changed to multiplication, then you simply follow the rules. There's one exception, is the non-permissible values. Remember, it was just the denominators of the two expressions before when we did it. Now it's going to be the two denominators plus the numerator of the what you're dividing by. And the reason is because once you take that and you divide it, it's going to change into multiplication. So the numerator is now the denominator, so that has to look at it as well. So it's just there's going to be more restrictions on the non-permissible values. That's it, though. Okay. So the first one here, we'll rewrite this as 5x to the power of 4 divided by -2, and then this gets rewritten as 6 over 25x squared. Okay? So we change the division to multiplication, and we take the reciprocal of the second rational expression. Okay? And now what we'll do is we'll multiply this. So this one's, there's nothing to be factored in this one. So we actually do multiply this. So we get 5 multiplied by 6, which is going to be 30. And then it's just x to the power of 4. Then we get -2 multiplied by 25, which is 50. And that's going to be x to the power of 2. All right, and then we can divide and simplify. So 30 divided by -50 will simplify to negative. You can put the negative out front or with the 3. We normally, it's a rule of thumb, you don't leave it in the denominator. And then, so you can put it as 3/5 with the negative out front or the negative in the numerator. I wouldn't leave it in the denominator. And then the x to the power of 4 divides by x squared, leaving you with x to the power of 2. We subtract the, don't divide them, subtract them. So we're left with -3x squared over 5. And remember, the non-permissible value comes from this denominator, which is nothing, and also the numerator of what you were dividing by. So obviously x cannot be equal to 0. Okay? So x cannot equal 0. Bring that over to the left margin. I don't have a lot of room for them and up here like I usually do, so I'm just going to put them at the bottom. Okay? And again, that's up to yourself. Okay? So next we're going to do is we're going to do B. Again, what we'll do is we'll copy. I'm going to steal one from the book. So now what we're going to do, instead of putting the multiplication sign in, I think what we'll do is we'll start putting in brackets, right? So just kind of eliminate that. So it's going to be x plus 2 over 4x minus 5. These numerator, remember, we're going to get rid of the division, so now we're going to put multiplication. So I would just leave it as brackets like that, if you wish. So then that's going to become 4x minus 5 over 2x plus 4. And while you're doing so, you might as well factor the 2 out of that right here. So we know that we have a GCF of 2. So the 2 can get factored and becomes 2 bracket x plus 2. I'm going to do that simultaneously. Now we're going to put it all over one fraction, okay? Right? So make it one big rational expression. So this is where essentially the brackets are going to be removed, right? Okay, so just get roll brackets all together. We get x plus 2, then brackets. Don't have the big brackets, but I'm just showing you. You'll see it like this sometimes instead of multiplication of the x I showed you. It's up to yourself how you want to express that. I'm okay either way. And then 4x minus 5 and 2. So 2 in fact to x's. Okay. Alright. So at this point in time we're going to factor any different. This first one's a lot different than these ones that we're factoring, right? We didn't have to factor any here, so we just simplify right away. So the x plus 2 is gone. The x plus 2, you divide out equal 1. X minus 5 divides with x minus 5. Leaves you with 1. So you have to put that 1 in there. Get rid of the brackets on the 2. So it's literally simplifies down to 1/2. It's pretty neat. Don't forget about your non-permissible values based on restrictions. And remember, restrictions are not only the two denominators here, it's also the numerator. So it's going to be the denominator of the first rational expression and the numerator and denominator of any rational expressions after that when you're dividing. Okay? So 4x minus 5, that would be 4/5. You guys are aware. And then the x plus 2, so identify these. There's not 3 of them because 2 of them are the same. Like some people are saying, why isn't there 3? Well, because you don't have to rewrite the 4/5 twice. It's not necessary. Or the 5/4, I should say. Let's look at example C now. You can factor it and then switch to multiply, but I always switch to multiply so I don't forget. Again, it's completely up to yourself. So all I'm going to do is one big rational expression here. Okay. All right, we're going to continue on with C here. I'm going to factor the first one for you. The first one is two numbers multiplied together to give us -18, added together to give us -3, and that would be -6 and +3. Again, what you're seeing on your screen is from the previous question. And the denominator will be, that is a perfect square trinomial, so it's going to be x plus 3 and x plus 3. Okay. And remember, I'll just do this all in one line now. I think we should be comfortable with this now. So remember, the denominator in the second rational expression will become the numerator because it's going to be multiplication. So what you see, the x squared plus 8x plus 15 will come to the numerator, which will be x plus 5 and x plus 3. Two numbers multiplied together to give us 15, added together to give us 8 would be 3 and 5. So the denominator is going to come from the numerator because we divided. So remember taking the reciprocal there. So we're going to have x plus 1 and x plus 2. Two numbers multiplied together to give us 2, added together to give us 3. So there is our multiplied, factored, rational expression. Now we're going to divide out any terms that are the same. So we have an x plus 3. That'll divide with the first x plus 3. We have another x plus 3. And that'll divide with this x plus 3. And again, I did that again one other video. My apologies. I'll cut that and I'll drop that down here. I should have did it with that one. My apologies. And we are all set. And that cannot be simplified anymore. Now we'll write down what the x values can be. Remember, it's not only the denominators now, because if you're dividing, it will be the numerator and denominator of what you're dividing by. So essentially it's going to be all your denominators and the last two in the numerator here. So x can't be -5, -3. You're seeing that the 3 is there actually 3 times, so we don't have to put that in, the -3, -1, and -2. So -2. Alright, so these all here in the denominator, and again, you don't have to write the number that's there twice, it's not necessary. Those are your non-permissible values. And again, we're going to use those more when we get to equation solving. And the last one that's going to go with the dividing is, it says simplify the following expressions and identify any non-permissible values. It looks difficult, but there's just a few different things happening here. It's not too bad. Okay, so the first one, what we're going to do is we will factor out 4, right? I'm going to grab a denominator, a fraction here, sorry. Thank you. And we're going to take a look at this, and what do we have? The numerator there, we can factor out a 4 in the first. Oh, factor out a 4 from the 4x plus 20, so it becomes 4 bracket x plus 5. We factor the 4 to the 4x plus 20. Alright. The denominator doesn't change, it's just going to be x plus 6. Let's multiply the second rational expression. Again, nothing can be done with that, so we just leave it. Remember, we're dividing, so the denominator here will become the numerator, so it's going to be 2x plus 8, and we notice we can factor out a 2, so that leaves you with 2 bracket x minus 4. Alright, and the denominator here, that's a difference, so it's going to be x plus 5, difference of squares, there we go, and then the x plus 6, there's nothing we can do with that. So denominator. Okay? So let's write in the values of x that will give us the non-permissible values. You can put it up here this time because we have lots of room. So remember, it's going to be all of this denominator in the first expression, the second denominator, and then both the numerator and denominator because you're dividing. Okay? So that becomes negative 6, negative 5, right here, negative 6, negative 5, positive 5. You don't need negative 6 again, but you will need the positive 4. Okay? So it's going to be these 4 values. Now let's divide out any terms that we can. We can get rid of an x plus 5. Oh, I'm going to copy that and then start getting rid of the next line there. So we get x plus 5, and that's eliminated. And the 4 and the 2 can multiply together to give us 8. You want to do that now at the same time. So the 2 here and the 4 here gets multiplied together. If x minus 4 is there twice, you can leave it like that. I'll show you another way to express it, which will be fine. Don't forget about dividing the x plus 5 like I did before. I jumped the gun there. My apologies. So that is essentially the expression, or you can go a step further if you want. This step is not necessary, but because they're both x minus 4, we can take that and we can decide to, if you're right, we can square it, right? Because there's 2 of them. Just another way to express it. You may see it written like this one time. And same with the denominator, is an x plus 6 twice. So again, you could express that as x plus 6 all squared. Again, it's not a necessary step, but either answer is suffice. Okay? And that's it for this example. I'll bring up, there's the homework questions. Homework page 327, number 1, 2, 4, 7, 8, and number 12. Okay? Some practice there for, and these are with the multiplying and dividing. Alright? So thank you very much. We'll see you again in the next video when we start 6.3 adding and subtracting rational expressions.